x squared, the y values, in other words, x squared will be between 0 and 1. Great. Okay, slowly but surely, I'm building my function. So I got the x squared to be between 0 and 1. Now I want 1 plus x squared in the middle. So what should I do to all three sides to get my 1 plus x squared in the middle?
Add 1.
Exactly. So 1 less than or equal to 1 plus x squared less than or equal to 2. Because these are all positive numbers, I am allowed. Otherwise, I'm not. It's like 2 less than or equal to 3. Yeah, I can take the square root. It's true. Same thing here because they are all positive. I can say the square of this, square of this, and the square of this. The sequence of symbols will stay the same. So 1 is less than or equal to the square root of 1 plus x squared, which is the square less than or equal to the square root of 2. Guaranteed. I got it. I have the function in the middle. That's our function. And I have lowercase m on the left and uppercase m on the right. So now all I have to do is do this. Of course, between -1 and 1. The middle is carved in stone. I cannot do anything to it, and I don't even want to. They're not asking us to determine this. And here I know how to determine. Remember, it's b minus a. Or you write that the square root of x, the square root of 2 is outside. Let me just show, since we're practicing anyway. So let's start with this one. So the integral from dx from -1 to 1. What function prime is 1? What function prime is 1? From -1 to 1, I plug in 1, and I subtract when I plug in -1. Similarly for the other one. Oops. The square root of 2 goes outside, and I get the same thing. It's the same integral. The integral from -1 to 1 from 1. So then I know that this side is 2 the square root of 2, and I know that this side is 2. And that's exactly what they wanted us to determine. Just show that that is between those two. They're not asking us to determine anything. Any questions?
That last step kind of felt like magic. How did you end up showing the twos on the outside and not?
Yes, very good. I calculated this. X prime is 1. Evaluated from -1 to 1. When I plug in 1, I get 1. But I have to subtract when I plug in -1. So that's +1. So 1 subtract when I plug in -1. Is that better?
No, I just wanted to make sure. So this particular. Okay, I got it. I understand.
Is it better, Sean?
Yes.
And on this one, the same thing. So I took the square root of 2 outside, and then I get the same thing. And I got the 2. So with the square root of 2 in front. Because fundamental theorem of calculus says f of b, of the top, subtract f of the a, of the lower limit. Is that okay?
Yes.
Okay. In our next step, I would like to, our next step is half is done, but we didn't practice enough by far. So let's go to the fundamental theorem of calculus. We have not talked about part 1. I will. in the next few minutes, but I want to practice Fundamental Theorem of Calculus Part 2, which we already know. And this is related to Part 1. These two are related. So I just want to practice this, and then I'll come back to these two. Okay, evaluate the integral. Anything you like, use Part 2. Not yet, because we haven't talked about it. Oh, Part 2, yes. Well, we haven't talked about Part 1. So Part 1 is this piece. Use Part 1, we don't know yet. Just give me a few minutes to practice. I would like to practice. We already did several examples, but I don't think that's enough. We looked at the different examples. So I'd like to choose between 25 and 54. So I would like to start with 31, and then you'll choose the next. In 31, we have the integral from 0 to 4, t squared plus t to 3/2 dt. Okay, so it's all about the antiderivative. The antiderivative of t squared is t to the 3rd over 3. How do I remember this? When I differentiate this, I have to get that. 3 comes down, subtract 1 from the power, and that's what I get. Plus 3, t to 3/2 plus 1. But 3/2 plus 1 is 5/2 over the same number mandatory. And the integral from 0 to 4. So bring down 3/2 and subtract 1 from the power. Right? So is this clear? So bring down 5/2, simplify, and subtract 5/2 minus 1, and you get 3/2. That's what I meant to say. So we plug in 4. Luckily, when I plug in 0, it's all 0, so I only have to plug in 4. 4 to the 3rd, 64 divided by 3, plus I flip 2/5, 5/2 into 2/5. And then I plug in 4. But here's what I do. First I take the square root of 4, which is 2, and 2 to the 5th is 32. Another way would be to just plug in the calculator and take 5/2. That's the same thing, but of course I will always take the square root of 4, which is 2, and 2 to the 5th is 32. Okay, so this is 64 divided by 3, and plus 64 divided by 5. Of course I'm going to factor out 64. I'm going to find the least common denominator, which is 15, and then I have 5 plus 3. I'm not going to mess with huge numbers. So now all I have to do is multiply, because this is 3 and 5, and I cannot simplify. 2 and 3, 48, is it 51? Correct me if I'm wrong. 32, 2 and 3, 48, 51, I think I'm correct. If I'm not, let me know. Okay, so now your turn to pick anything you want, or if we got the idea, then of course this has to be split into 2 over the square root of x and x squared over the square root of x and simplified. We can't do this otherwise. Here you will have to distribute to find the antiderivative. Yeah, let's talk about this one, 39. It's a good one. So we have the integral from 1 to 3, from 2x plus 1 over x dx. Okay, always remember I have to check, is this function continuous here? Yes, it is. So the first part is easy, so it is 2x squared over 2, and I will end up simplifying these. But remember, what function prime is 1 over x? This is very important to remember.
Natural log x.
Very good, of the absolute value of x. Awesome. Always remember the absolute value. You can say there is no need because these numbers are positive. I agree. I will remove it. I completely agree with that. So when I plug in 3, I get 9 plus natural log 3 minus, careful, when I plug in 1, and minus when I plug in 1 here. But how much is natural log 1?
0.
0. 9 minus 1 is 8, so 8 plus natural log 3. Awesome. Thank you so much. What about 40? Can anyone give us the answer to 40? In a blink.
Yeah.
Very good. What is it?
Theorem.
Of course. Very good. Awesome. How will you do this one? Of course, you have to split it. Y cubed over y squared is y. 2y squared over y squared is negative 2. And negative y over y squared is negative 1 over y. How will you do this one? Well, you have to cube it first. We don't have any other way. We don't have other techniques yet. We will learn one technique after simple integration. Simple again, split the fraction. Split the fraction, take the square root of 3 outside and z to negative 1/2. Very simple. It's a hyperbolic sign from 0 to 1. Yeah, let's look at 49. Good. In 49, we have the integral from 1 over the square root of 3 to the square root of 3 from 8 over 1 plus x squared dx. Perfect. Awesome. I don't like constants. They're in the way. Well, sometimes they are useful where they are, but not this one. Do we know a function whose derivative is 1 over 1 plus x squared? Oh.
It's a tan H, I think. Oh, arctan, yeah.
Excellent. Because our tangent prime is 1 over 1 plus x squared. So now we'll plug in the square root of 3. And we subtract when we plug in. I prefer the square root of 3 over 3 rationalized. And remember, this is very easy. I always say to my students, don't even think in terms of tangent. Just think in terms of the smallest angle, 1/2 over the square root of 3 over 2. So this is for pi over 6. And for pi over 3 is reversed. So that's for tangent, right? Tangent of pi over 6 is sine over cosine. Tangent pi over 3 is sine over cosine. So when you flip this, you get that 1 over the square root of 3, or the square root of 3 over 3, which is this. When you reverse this, you'll get the square root of 3. When you multiply by the multiplicative inverse, you get this. You don't have to think in those terms. You just have to remember sine and cosine. So this is 8 pi over 3 minus pi over 6. So this is 60 degrees minus 30 degrees. Obviously, it's pi over 6. And you can simplify by 2 to get 4 pi over 3. Good. I think we can move on to, we just looked at an example like this. And yes, we're going to come back to this. Or maybe we should do an example with the area. Okay. So let's say I'll start with 55. Let's take a look. In 55, they're asking us, this is a huge chapter in Calc 2. There is really no need to do it right now here, but these are very, very simple situations. But it's a huge chapter of determining areas and volumes in Calc 2. I just finished that with my Calc 2 class. Okay, so let's look at 55. and we have y equals the square root of x, y equals 0, x equals 4. Sketch the region and find the area enclosed. Fine, no big deal. So I'm graphing the square root of x between, so this is y equals 0, this is y equals 0, this x-axis. X equals 4, 1, 2, 3, 4. So these two are taken care of. And now I have to graph this function between 0 and 4. So the square root of 4 would be 2. So this is 2. So 1, 1. So this is the graph. So they are asking us to determine this area. Now we know how, right? Because this is y equals 0. So it should be the integral from where the area exists between 0 and 4 from the upper function minus the lower function. But the lower function is the y-axis. So there is no need to write it like this. But this is what we do in chapter 6 in Calc 2. So if we have something like this, this is the upper function and this is the lower function, and I want to determine this area, it will be f of x minus g of x between 0 and 4. But here there is no need because this is the y-axis, the x-axis, which is y equals 0. So how do I determine this? It's x to 1/2. So x to 1/2 plus 1 is 3/2 over 3/2 from 0 to 4. 2/3. The square root of 4 is 2. 2 to the third is 8. So times 8. And there is no reason to plug in 0 because I get 0. So this is 16 over 3. But again, there is a huge chapter coming up for you in Calc 2, chapter 6. Okay, so what I would like to do now is finally talk about Fundamental Theorem of Calculus Part 1, and then we'll look at some examples. So let's talk about that first. I think I'm on page 9. Yes, I'm on page 9. And let me start a new video because I got